Okay. Uh-huh. Okay. All right. Let's. I'll bring you over here. All right. Okay, we'll get started in just a couple minutes. Let's give everybody a couple more minutes to get logged in and ready to go. For the folks that are here, can you hear me okay? All right. Good, good. Hopefully you've started work on the prerequisites, just a few things you need to have going to get the most out of the workshop today. If you have not, go ahead and follow the steps on the screen. Go and get an OpenAI API key, and then sign up for XetHub and go through the XetHub installation process. I'll walk through this during the workshop as well, but if you have it going, it just goes a lot faster. And if you're working on a Windows machine, it's really important to start the setup process early because we need to install the Visual Studio toolchain, build chain, in order to install a couple of the Python packages needed for the generative AI application we're going to build together. And downloading that on my Windows machine took a few minutes because it's 9 gigabytes to download. Okay. Let's see. Does anyone have any questions before we get started while we're still waiting for others to join in? I'm happy to answer any questions. Go ahead and share them in the chat, and then I can try and address them. Okay, so two good questions in the chat. Ruben asks, Python 3.9 or at least 3.9? 3.9 or 3.10 will work. 3.11 will not. One of the fun things about Python is that minor versions break backwards compatibility. And for a lot of machine learning workloads or AI workloads, the packages that are used often are not updated as quickly because they rely on system libraries, system binaries, and often need to be compiled. So I know that what we're going to do today works on Python 3.9 and 3.10. If you have 3.11, there's a fair chance that the training step will fail. And that's because Torch, actually installing requirements will fail because Torch, the PyTorch package is not supported on Python 3.11 yet. But yeah, maybe it's been updated since the last time I tried it, Martin, and you're right. Maybe it'll work. But I wanted to make sure I know everything works with 3.9 or 3.10, as 64-bit 3.9, 3.10. Second question, Jonathan asks, is there a recording available after the call? Absolutely. In fact, you'll get the recording as soon as the session sort of completes. It takes a couple minutes to process. And so you'll get a follow-up email which has the recording and the materials that we that we have, the workshop steps. So yeah, you'll have the recording. Well, Apurv, that's a great question. We have a Discord community, and so I'll share the link to that. In fact, let me see if I can. Let me dig that up right now, and I can share that with you. And in fact, a fair number of people from, this is the third workshop session that we've run for MyGPT. And we've had quite a few folks participate in Discord from the sessions. I've just shared the Discord, the link to our Discord server. Go ahead and join. I won't look at that during the session, but because I want to pay attention to questions coming in through the chat. But that is absolutely the best way to get in touch with me or with the rest of the XetHub team after the session today. All right, so we're 5 minutes past the start. I think it's time we get going. So so let's do that, and other folks can join in when they have time. So normally I'm running these workshops with my colleague Jonathan Alexander, but he needs to be out today, so you won't get to meet him unless you join our Discord, and then you'll get to talk to him all the time. But I'm Rajat Arya. I'm a software engineer by training. I've spent the last 20 years in the technology industry, working primarily on large-scale distributed systems. And the last 10 years or so, over 10 years now, I've focused on building systems for machine learning. I started as the first employee at a machine learning startup called Turi, which was acquired by Apple. And inside of Apple, we built the machine learning platform that all of Apple relies on. One of my earliest customers, the part of the platform that I worked on was the data platform inside the machine learning platform. We got to publish a paper at Sigmod that talked a little bit about our work in building that data platform. And I can finally talk about one of my earliest customers, the Vision Pro team, were one of the early adopters of that data platform inside Apple. My co-founders and I left Apple a couple years ago, and we started XetHub to take many of the things we've learned over the last 10 years in building systems to support machine learning and enable teams all over to scale their projects and make machine learning easy, make machine learning collaboration something as simple as software engineering collaboration has been for the last 15 or 20 years. So I'm by myself today for the workshop. What that means is you'll sometimes see me looking over this way. That's only because the way that our the software for the workshop works, if I can't see the chat, if I bring the chat into the same window that I'm sharing, then you'll see an infinite mirrors. So I have to look over to the side to look at the chat. So whenever I do that, know that I'm not ignoring you. In fact, I'm looking at the chat. Please use the chat for asking questions and ask questions throughout the session. I'd love to stop and sort of address questions as they come up. What I want to cover today is we'll start with a quick demo of where you will be by the end of today's workshop. Then I'll go through a few slides to kind of walk, to explain the app architecture and give a brief overview of what generative AI applications are. We'll cover the tech stack involved for today. And then we'll go through the hands-on part of today's workshop, which is the majority of today, for building your own MyGPT application on your own data. All right, so let's get into it. So we'll start with a demo. So I'll break out of slides and I'll bring you over to this browser window. Can you can everyone read this? All right, I see some thumbs up. So I want to show you where you'll be by the end of today's session. So what I have here is MyGPT, and it's tailored on a data set that I care about. I like movies a lot, so I built MyGPT with movies so I can ask questions like, who played Neo in The Matrix? Keanu Reeves played Neo in The Matrix. So what I'd love to do is get a couple of movie-related questions that we can ask this generative AI application that I've built. So go ahead and write them in the chat. While you're doing that, I'll show you a little bit about this data set so that you have a sense of what is in this movie's data set. So this data set is 24 megabytes in size. It's about 35,000 movies. And a couple things you can notice when you look at this quick sketch summary that XetHub provides over CSV files, you can see that the release year is from 1970 to 2020. So it's Hollywood movies over the last 50 years or so. Other nice things you can see, categorical variables like the genre. You can see there are more dramas than any other genre of movie. And you can see who's in the cast, who the director is, and you can see a plot summary. So a summary of the plot of the movie. So that gives you a sense of what's in the data set. You can also see kind of a raw preview of the first 5 megabytes of the CSV file. But I find the summary to be a little easier to look at. Okay, I see one of the questions that's come in. I'll try it. How many movies has Kevin Bacon starred in? And I think this is going to be a pretty tough thing for this app because counting is not one of the things that LLMs are good at. But let's see how we do. All right, did a pretty decent job here. Kevin Bacon has starred in 70 movies. So that's not bad. That's pretty good. Let's try another one. How many Fast and Furious movies exist? So Fast 10, I think, was just released. It says there are 8 Fast and Furious movies. That makes sense because my data set ended in 2020. And then I like that Ruben asked, what is the one rule about Fight Club? Let's see what we get from this. These are all good questions. I suspect this may be difficult. Yep. So my app says, hey, I don't know. And I'll walk through what that means, why the app says that as we get into building stuff. But we can ask a couple questions that I think are kind of neat. Who are the actors? Who are all the actors that have played James Bond? Ruben, I like that. Yeah, that's what Fight Club would say too. So the actors that have played James Bond are Daniel Craig, Pierce Brosnan, Timothy Dalton, Roger Moore, and George Lazenby. This is incorrect because it is missing Sean Connery. And so that's an interesting thing. I'm curious if I if I run the same question again. Nope, I'm still getting, so this is incorrect. I mean, all of these actors have played James Bond, but it's an incomplete list. Let's try another question. Did Chris Pine play Captain America in Captain America? Not sure if you know the answer to this or not, but this is correct. Chris Pine did not play Captain America. Instead, it was Chris Evans. So this is the idea of what you can do with your MyGPT at the end. You can even do a couple more things with this. So not just trivia, question and answer type stuff. You can say, write a note to a friend encouraging them to see all the Star Wars movies. Make sure to mention why Star Wars is worth watching and include a couple emojis. So it's not just asking things about the trivia about your movie, about your data set, but you can have your generative AI application help you do some other things too. So you can see the response here. It's pretty good. The Star Wars movies are action-packed and full of adventure. You get to meet iconic characters like Luke Skywalker and Han Solo, and you'll experience the epic battle between good and evil. So this is just to give you a sense of what you're going to get by the end of today's session. You're going to all have an app that you can run that you can use to help you do things. I think of it as a personal assistant or your own AI assistant that's helping you build things based on your data. All right, so next, let's go back into slides, and I want to give a quick overview of generative AI applications. Any questions so far? All right. So a lot of folks have, I'm sure you've heard about generative AI. There's a lot of things written about it today, but what is it? Well, generative AI is nothing more than machine learning, but it's the thing that makes it seem new is that it's machine learning models that can create new content, or whose predictions can seem like new content. And so generative AI is all about the usage of machine learning to create, to generate new content. All of generative AI is built on top of a set of foundation models. Now, what is a foundation model? It's, again, just a machine learning model, specifically a large neural network model. What makes these neural network models special? Why are they called foundation models? It's only because they are huge, 100 billion parameters or more. The reason, and so foundation models are a class of models. There are specific types of foundation models, and the one we'll use today is called a large language model. And you use a large language model for text when you want the model to generate text. And so this is the sort of diagram to keep in your head. Generative AI is a category built on top of foundation models. There's a whole set of foundation models. The most common ones are large language models, but there are also foundation models for generating images, generating audio, generating video. Okay. So before I move on to how an app works, let me answer Mohammed's question. Yes, the example I showed was a CSV file, but other file types will absolutely work in your MyGPT. The way the application is structured is it works for any text document. So this can be what I'll do in the hands-on part is I'll use markdown documents that I exported from Notion. You can do the same from Slack or any text documents, and it will ignore documents it can't understand, like binary documents or other types of documents. So that's a great question. Okay, so what it looked like when I was using when I started off showing you the movies example, is that we hit submit, a request went off to the DaVinci model from OpenAI. By the way, the DaVinci model is the same LLM that ChatGPT uses, and we got back a response. And that's what it seemed like what was happening, right? The DaVinci model was able to answer questions about movies. Well, that's not how it works. Instead, the thing to remember about foundation models is that the foundation model does not change. But because it's so large, it can learn context and relationships in an unsupervised way. These foundation models have been trained on giant data sets. By learning context and relationships across the corpus of, across the data sets on which they were trained. So in our case, large language models are trained on text. So by learning the context and relationships across text, these models excel at manipulating existing data and incorporating information in the request for a prediction to generate output. What does this mean? So the foundation model doesn't change. So how does this app actually work then? Well, let's walk through it. So instead, when you click submit, what's happening is we take the input string and we call a different service from OpenAI that turns that input into a vector of floats, which is often referred to as its embedding. So it turns the input into its embedding representation. We do this so that we can execute a semantic similarity search against our embeddings vector database. And what this allows us to do is to find the document fragments that are most semantically similar to our input. We take those semantically similar document fragments, and now we put them together with the input, and we put those documents together as context with the input, and now we can create a prompt, and we send this prompt to the large language model, to the foundation model. And now we get our response from the LLM, and it tells us which document fragments were used. So what does this mean? Foundation models are tailored to your data because the app submits your relevant data along with your input. So how did we get the document fragments into the vector database in the first place? How did our app know which document fragments to submit? Well, that's our training step. And I'll say training in air quotes, because typically in a machine learning context, when you say training, you're referring to training the ML model. But we're not doing that here. The foundation model is already trained, but our training step is taking our data set, getting embeddings from the same embedding service for each of our documents and storing them into our embeddings vector database. So that's how we're able to train, or that's how our application is able to know to perform the semantic similarity search against our vector DB, our embeddings database, to know which document fragments to submit to the LLM. One way to think of it is you're asking the large language model, given this information, and by this information, I mean this set of document fragments, answer this question or address this input. That's how you're getting the foundation model to incorporate your data into its response, into what it generates. Any questions on this? Okay, good, 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 good. Oh, I see someone typing. I'll give a second for them to put in a question. Oh, and then they stopped. Okay. The next thing I want to talk about is the tech stack involved in building the application. What are all the parts before we get into the code and building the app ourselves? What are the things that you need to know about? So we already talked about the services a little bit, but there are two services we're using here. We're using OpenAI's DaVinci large language model. There are other large language models. But that's this is the model that's used for ChatGPT, and I think on most performance benchmarks, this is the not the fastest, but the best performing in terms of quality large language model available. To generate the embeddings, we're using OpenAI's text embedding service. You can swap this out. There's a whole bunch of embedding services out there. You can use a local model to generate embeddings. This is not something that you need to use OpenAI for. It's just convenient. There's less code because I can use the same Python package to talk to both services. And that's why I chose it. But know that you can adapt this as you'd like. Ajit asks a question, is the embedding vector database passed on as a prompt to the LLM every time? That's a great question. Not the entire database, only the relevant document fragments. So if your input was about Kevin Bacon, then the document fragments, so the sections of my movies.csv file that relate, that are semantically similar or close in distance to the tokens for Kevin Bacon, are what gets sent to the LLM. If my next question is about Keanu Reeves, then it won't be the same document fragments. It'll be the ones related to Keanu Reeves. So that's the way to think about it. It's not your whole database. It's the part of your database that's semantically similar to the input. Great question. Okay, so we talked about the services. Let's get into the code. What's the app actually built with? Well, this whole app's built with Python. So hopefully you're all ready to get into some Python code. The database we're using, our vector database, is Chroma. Now there's several vector databases out there. This is one thing you'll learn very quickly in the generative AI space is everything is moving really fast. So there are many vector databases. You can pick whichever one you'd like. The Chroma has been around for a long time, and so I use that one for MyGPT. For the UI, we're using Gradio. If you've used Gradio before, then you know that it's a Python package that makes building web applications very easy because you don't have to write HTML, JavaScript, or CSS. You can just write Python. And it makes building interactive web applications pretty straightforward. And for the glue between for the glue, we're using LangChain. And what I mean by the glue is LangChain is responsible for abstracting away the vector database and the large language model. So it's responsible for querying the vector database to find and taking the results of those to create the context, taking the input. So LangChain is a very powerful package that acts as glue for building applications that talk to large language models. And so we're using it today in this application to query the vector database, build the context, add the input, and then generate that overall prompt to send to the large language model. So this is all the code, but for this project, the code is insufficient. So unlike most software projects where the code is all you need, for generative AI applications, you need more. You need the data and the model. Now, I I'm using model maybe with air quotes because this is not a trained ML model, but instead our embeddings vector database is the model for our application. And the data is our corpus of documents. So to manage the code, the data, and the model, we'll use XetHub. And if you haven't used XetHub before, it's like GitHub, but it's designed specifically to work on large projects like generative AI applications. All right, that's it. Let's get into the code. So I will drop out of PowerPoint and we will get into, let me bring up the hands-on steps that we're going to go through to get started. So first, let's sign out of XetHub. Let me see, where did my hands-on? I want this document to open. Aha, I already have it. It's just minimized. Okay. So this is what we're going to do. So I want to leave these steps up. So if you haven't done the prerequisites yet, definitely get started. So we'll start by signing in. You can sign up for GitHub for XetHub with just a few fields, or you can sign in with your existing GitHub credentials or GitLab credentials. I'll use my GitHub credentials. So what we want to do is take the MyGPT repo. So let me take a second and just kind of walk through what we're looking at on the XetHub UI. When you sign in, you're going to see repositories. This should look and feel a little bit like GitHub, shouldn't seem too strange. If it's your first time signing up for XetHub, then you're going to be presented with our quick start. And the important step for today's workshop is to go through the first piece of this, which is install and setup. And what this requires is installing a Git extension on your machine. So depending on what platform you're on, you'll install the appropriate binary, creating a token, and then setting up that token on your machine. So these are all the steps to make sure XetHub works correctly when you're working on a XetHub project. So go ahead and do this step. Hopefully all of you have gotten this done already. This only takes a couple minutes, if even a whole minute. And then I'll move on to starting work on the actual project. Oh, look at this. Martin added Arch Linux binaries. That's fantastic. We do support Linux, but we deploy it, I believe, as a, what's it called? As a tarball. Okay. So once we've gotten this, once we've got your machine set up for XetHub, then let's go get the starter package, or the project that we're going to work on, which is MyGPT. So some of you have already done this step, but what you want to do is fork this project. So like you would with any other repo, you want to fork it. And then I recommend making the repo private. And I'll walk you through the steps for that. So if you're familiar with public repositories on GitHub or GitLab, you can easily fork them, but then you can't make them private. But I'll show you how to do that in XetHub. So we'll start by forking. And I'll call this workshop. And because I own the thing I'm forking, XetHub automatically sets the ownership of this to my organization. But that's okay. I'll change that too. So I'll click Fork Xet. And now I have, I forked this. You can see it's forked from the MyGPT from Rajat Arya, MyGPT. I'll go and transfer this ownership back to me because I don't need XetHub to own it. I want to own it. This is a step you won't have to do that I do, so you can ignore that. But the step to make this private, which I recommend, otherwise everyone can see whatever data you're going to put into your project, involves you go into the settings. So from your repo view, from the top level view, click on settings, and then scroll down to the danger zone and convert to regular Zet. So what this does is it breaks the parentage. So it's no longer a fork of another, it's no longer a fork of a repo. So the fork has been converted to a regular Zet repository. Great. And now I can mark my repository as private. So I go back into settings. Oops. Yeah. I'll go back into settings, click on make repository private, and then click update settings. Now this is optional. You can choose to make your MyGPT public. You can choose to just fork the MyGPT project and go off of that. But I think this makes the most sense because now you can put your private data into your project and no one can see it. So you can see that my repo is private and this is the one I'm going to work on. So this is the first two steps of what we're doing. Now that I've got my project all set up, let's bring it to my machine. So I'm going to copy my clone command. And so I click on the copy, and then I'm going to go to a terminal. And we'll use a new terminal. So I'll minimize this one. And I'll make this a little bit bigger. Like that. And on a directory of my choosing, I'll paste the command I copied. So, or asks, where can I rewatch the lecture? After the session, you'll get an email with the recording. And so you can watch everything afterwards during that. And this also helps in case you fall behind and you're not keeping up with you're getting stuck doing a setup step or something like that. You don't worry, you can always go back and kind of replay parts and catch up that way. So I cloned. I could have run git clone for this, but running git zet clone not only ensures that the client is set up correctly, that git zet is set up correctly, the zet extension to git, but also this is faster because we can do things in parallel where git clone cannot. So now I can go to MyGPT Workshop, and this is normal Git. My shell knows this is a Git repo. And it's showing that it's yellow, meaning that it's that the repo branch is clean. So if I look at Git status, there's nothing. The working tree is clean. There's no untracked files. Yes, Charles. Absolutely, you should get that version of Git Zet when you go into the install. So if you go to Quick Start and click Install and Setup, when you click on Install Git Zet, you should get the latest version, 0.10.1. Oh my goodness, we have no package for 0.10.1. Thank you, Charles, for opening an issue for that. We'll get that fixed. We did the deployment earlier this week. I want to say on Monday, maybe yesterday. And looks like we didn't get the package uploaded. So that's something we'll get addressed right quick. Thank you for opening the issue for us. So yes, 0.10 is available at the link that Charles provided. You can also find it if you go to Zet Data, Zet Tools in GitHub, and then look at our releases. You're absolutely right. We have the Mac Universal Tarball, but not the PKG. Everything we're doing today will work with 0.10. So you can get the PKG from 0.10. Thank you for catching that. That's great. Okay, so we had cloned and we are on our machine. So now the next step is setting up Python. Oh, well, let's make sure our OpenAPI key is available. OpenAPI. I say that every time. OpenAI API key is known to this shell. So I have this saved in a file, and now that API key is known to my shell. Next, let's set up my Python environment. So there's a bunch of ways you can do this. I tend to use the thing that involves the least number of Python packages. So I will create a virtual environment in this local directory, and then I will activate it so that now I can install the requirements needed for MyGPT. And just to show you what's in the requirements, it's not that many packages, but they install a bunch of other packages. So you can see ChromaDB we talked about, Gradio you come back over here. Gradio we talked about, LangChain we talked about, OpenAI we talked about, and OpenAI depends on TikToken for its embeddings, and then URL lib3 for requests. So pip install -r requirements, and one other indication that that all of the projects involved with generative AI are moving really quickly is almost every time I run this, there will be a new version of one of the dependent packages to install. Now, for all of you, I did this earlier today, and that's why my local machine has all of these packages cached. But when I did this yesterday, when I ran this earlier today, several packages updated from when I had run it yesterday. So just keep that in mind, that things move really quickly, and a lot of these packages are updated almost daily. So if you want something that's fully reproducible all the time, I recommend freezing your environment, which will lock all of the versions of all of the packages that got installed. I don't do this in the MyGPT template or in the MyGPT repo, because many of these packages are not at the specific version, are not supported across all of the OSs. So I wanted to have the minimal set of packages so that the dependencies could get installed on whatever so running pip freeze will keep all of the packages at this version, which works for Mac OS, for my version of Mac OS and my version of Python. May not work the same. These might not be the right package dependencies for your OS or your version of Python. Charles asked a good question. Can I put JSON documents in the data folder? Absolutely, as long as they're text. The document loader I'm using will parse them. It may not parse them as effectively as a more sophisticated document loader, and I'll walk through that part when we get to the code, which is coming up. So the next thing we're doing is putting our documents into the repo data directory. So just like Charles asked, we should put the documents we want to use for MyGPT into this directory. So there's a dummy file here. I'm going to copy a couple. You can copy or move the data you want to use. And so I've done that. I've got my data in the data directory. In fact, when I run git status, you can see my shell changed. It's orange now because there are untracked files. And so now I've added my data. Let's commit it. So I've added 2 megabytes of data, which are my documents. And let's check those in, and then let's push them. So what you can see here is all of this is just being done with XetHub, and it's just normal Git operations. So you're not doing anything special in order to use XetHub. And you can see it's maybe a little hard to read, but there's a commit from 21 seconds ago that I just pushed. And you can also see the file types changed. Now we're up to 94% text documents, whereas previously we were at 70% or something. So good, I've got data, but I don't have my app ready yet. So let's train it. And remember, training in our case is not actually training an ML model, but instead generating embeddings over my data set, my corpus of documents, and then storing them into my embeddings database, my vector database. So while this is running, I want to walk you through a little bit of the code. And so that way you get a sense of the architecture of the app, what the code actually looks like. So we'll let that run in the background, and I'll just walk you through a little bit of the code. Let's see. Charles asked a good question around how documents are loaded and parsed. Let's start with train.py. So that's what we just ran, Python source train.py. You can see this isn't doing a whole lot. It's calling index.fit. The index, it's instantiating the index object and calling fit on it. Okay, so let's go look at the index object. So the index object is my wrapper, my class that wraps LangChain, and it's the vector DB. So it's the brains of my application. It is the business logic. It is that middle tier of a 3-tiered application. It's not the UI, and it's the tier that handles the business logic and writes the and works with the database, with the storage layer. So I won't go through all of this code, but this is all pretty standard Python code. I'm using a lot of defaults that LangChain offers. So there's a lot more sophistication you can do in how you build your document parsing, how you split the text, how much overlap there are between the document fragments. So there's a lot of knobs you can tune here, and I won't be able to go into even half of them, but just know that I wanted to give you something you can start with, and then you can really dive deep into into this code and into the knobs to tune. So I'm using the default text splitter. I'm using OpenAI's Python package as my large language model. I'm instantiating Chroma as my vector store. And here, this is when you reload, we're going to load off of the file path locally. But what we're running right now is fit. So let's look at what fit does. Here's fit. Fit deletes some things and then calls build vector store, which happens to be right up here. So what am I doing to build the vector store? I am using a text loader, which is one of the oldest document loaders available in LangChain. And I'm saying, given the file path to the document, auto detect the encoding, load it, and this is coming from a list of files that go from the data path. And this is a fun Pythonic way of doing iteration, building up a chain. Now I split those documents into fragments, and then over those fragments of documents, I hash them to get IDs. And from that, I use those IDs to build out the vector database by getting embeddings for each of those document fragments. And then I wrap my vector store in an index wrapper. And that's basically it. I run a couple sample questions just to make sure that things are working as expected, to validate my vector store before I save it. So this is the main brains of my application for training. And I'd walk through a little bit about how we load the vector store once it's been saved. But querying it, which is what the UI does, is calling this query method. And what it's passing is, it passes in the question, which, there's a default question, but it passes in the input that you specify. And here I'm using a retrieval question answer with sources chain from LangChain. There are other chains. So for building a chatbot, you would likely use a chatbot chain. So just know that this is another area of customization depending on the type of application you want to build with your LLM. And so I mentioned LangChain is the glue. This comes from LangChain, and we are saying use this LLM and use this vector store as the retriever for context. I should also mention chain type stuff. That's not an arbitrary string. There are other chain types, but the default one is named stuff. So then we take so then we return this chain, and that's how the query is. That's how we issue a query. Now, the last thing I'll show you is what does the UI look like? What does Gradio's UI look like? It's really, really simple. It uses blocks to sort of do layout between rows and columns. And most of this code is like input validation, or making sure you have your API key and that there's data and that there's a model. And assuming you have all of those things, then you see we've got the text box, which is the question. And then we've got the outputs are 2 text areas. And here you can see there's, when you click, then we are calling this helper method, which takes the input and the outputs, and it formats the outputs to show you the sources. But that's it. This is a really, really simple UI. Okay, how do we do? 90 seconds for us to complete our training step, but we're good. Now we can run our app. So I'm running Gradio source app.py. You can see 2,300 embeddings. We're loading those 2,300 embeddings. And now we'll be able to host the local app. There we go. So I haven't told you what my data set is. So maybe we can just, we'll ask for some summarization. What are these docs about? And this is tricky, right? Because we're asking how many fragments need to get submitted in order for the LLM to answer. Well, this is good. These documents are about marketing and include topics for discussion and notes. So now you have an idea of what my documents are about. I've taken the marketing workspace from Notion for XetHub, and I've exported it. And so I want my GPT to help me do my job. So I spend a lot of time talking with machine learning teams. And so maybe, so I write a lot of email. So I'm going to have my GPT help me write an email. Write an email to an ML engineer telling them the top 3 reasons to try XetHub. Include a few emojis, use a casual tone, and make sure to have a catchy subject line. The email should follow the format of subject. Let's see what we get with this, and then we can refine it. Hey, we got an email. So it took 20 seconds. I feel like things are a little bit, the OpenAI API is running a little slow, or maybe my internet's getting bad. But here we go. We've got an email written by MyGPT that looks like a pretty good starting point for me to talk about if I want to send an email to if I want to send an email to an ML engineer. This is a good starting point for me to have something. So this is good. I kind of wanted to show where this came from. You can see that things got cut off, and that's because there's only so much content. There's only so many tokens that are available in the large language model. So sometimes when your response gets cut off, you won't see the sources. You won't see what documents it comes from. So this is what I wanted to show you about where you can go with MyGPT. But I forgot to do something before I ran this. I finished my training, but I didn't check anything in. Well, why don't I do that? So let's remove my dummy file from the model directory, and let's add the embeddings, which are Parquet files. And here's something you can see right away: 55 megabytes. So you saw my input documents were 2 megabytes, but my vector DB is 55 megabytes. This is why generative AI applications get very big very quickly, and why using a system like XetHub is important. So I'm going to commit this initial model embeddings, and let's push this. And so here you can see that we have 55 megabytes. We break up all of the data in your repository using block-based deduplication. And what that means is we're submitting 16 megabyte data blocks, which is really efficient on the network and really efficient on disk. And so this way, in just a couple seconds, we've got this uploaded on my home internet. And now we can go back looking at this project. And you'll see now it's jumped up to 69 megabytes. In fact, if you take that movies project that I showed you earlier, let me show you what that looks like, which is slightly more, it has more commits, many more iterations on the embeddings. And you can see that this project is 16 gigabytes on disk, but stored with XetHub is only 5.2 gigabytes because of deduplication. So what have we done so far as we're wrapping up? We've got MyGPT Workshop running. It's been built using marketing documents and markdown files that I got from scraping the XetHub website and from the marketing section of our Notion workspace. And I've got it running locally here. Well, that's cool, but if I wanted to share this to others, I'd rather deploy this so other people, and I could then send a link to the app to my colleagues or to anyone I'd like to share it with. Well, in XetHub, we now support deployment of Gradio or Streamlit applications with one click. You click on capsules. We call this work capsules, and this is, we just launched this last week, so it's in limited preview today. So when you get to this screen, until you've been approved for access, you just fill out the form, and I will gladly give you access. You can tell us, you just have to tell us which branch, what type of app you're launching, where your entry point is. So for this example, it's in source app.py. And then I'm hoping you guys don't look too carefully, but I've got to put my OpenAI key into the thing. So we'll copy this over here, and then we'll copy that, and we'll paste it there, and then create the capsule. And since we just launched this, this is going to take a few minutes, so I don't want to make us all wait for this to happen. So I have one of these running already. So let me bring that up for you. That is this capsule. So on the other end of that capsule launching, this is what it is. The same thing we're running locally is now running at a URL that you can easily share. with anyone, and they can get to your running app without any work. I should mention that this repo is private. So if I send you this URL, you can't get to it because you're not a collaborator on my repository. But that's okay. I can add you as a collaborator and then you can see it, or I can make the repo public and then the capsules are public for anyone. So let's ask another question from our MyGPT that's now running off of the deployed instance, the deployed capsule. All right, XetHub offers usage-based pricing on the dimensions of compute, storage, transfer, with a free product also available. All right, that's pretty good. I mean, if we go to XetHub.com, our pricing is a little simpler than that. It's absolutely free for every public project. And then we have usage-based pricing based off storage and transfer. So not too bad for the running MyGPT that's hosted and running as a capsule in XetHub. So that's what I wanted to cover. I'll wrap up with a slide which talks about, well, maybe yikes. Let's share this so the whole screen gets it. Our Discord server. So if you please join the Discord, and that's the great place to continue the conversation. Or if you run into issues and you're watching the recording later and you'd like some help, that's the way to do it. And then we have a Python SDK that I haven't shown you today in the workshop, but you should definitely check it out. We are open sourcing it. The code is coming in the next few weeks. We just need to break our mono repo and split out our Rust code and get it ready to have out in to have in a separate repo. That's happening in the next few weeks. But today with PyZet, you can read and write directly to XetHub repositories from within Python. And so I find that to be really compelling. And so that's all I wanted to cover. I can stop sharing and spend a couple minutes answering questions. Ruben asked a great question. Charles, I think you're absolutely right that the temperature is one of the main ways to control how the LLM behaves. But the thing to know in general, Ruben, is you're not going to get true determinism out of an LLM. It's not designed that way. One of the challenges of a model being that big is that on each time you ask it for predictions, you can end up down a different branching path of the neural network. And so it's why getting deterministic answers from a foundation model is really hard. I'm not sure it's worth trying to get deterministic answers. I should also mention this is an active area of research. And so there's quite a bit of activity going to try and evaluate the quality of LLM responses and how to sort of measure the quality of your prompts, the prompts you're sending to the LLM along with the responses. Yeah, so Ruben's follow-up question, how does validation work in the LLM space? This is an open area of what is the fast chat? I think is a reasonable fast chat is one of the projects that looks to evaluate LLMs across multiple evaluating multiple LLMs. So this is Jonathan. This is Jonathan's username. So this is Fast Chat is a GitHub repo that we've pulled into XetHub so that we can. Right now on GitHub, you have to go and download each of the LLMs individually, and it's a real pain. Whereas in XetHub, all 111 gigs are available to you right away. And so that's the idea of. But Fast Chat's one of the projects that's around to help evaluate large language models. Mohammed asks, in the example where you got it to write you an email, it wasn't able to reference the source. Yes. Has reached some limits. Is there some way around this? So different LLMs have different token limits. So OpenAI yesterday announced a new 16,000 token GPT 3.5, which I'm actually interested in trying because I suspect it will you'll get a whole lot more. You'll be able to submit a lot more context and you'll get back a lot more. So I think that, you know, this is one of the things to look at when you're comparing different LLMs is how much content, how many tokens can the LLM offer? Charles asks, Capsules looks pretty cool. What are the restrictions for what can be deployed there? Arbitrary Docker files, Python repos with requirements, TXT. Really good, great question. So it's early. I'd love to get your feedback on this. Today we work with Gradio and Streamlit apps. So we're expecting a requirements.txt and an entry point, an app.py for either. And then we build up, we use a Python 3.10, 64-bit Python 3.10. And when we go to deploy, for collaborators only, let me go to one of my, oh, this is done. It deployed. Cool. Let me go back to one of my repos. I was working on a crime project. So this is what Capsules supports today. All Capsules run with 2 vCPUs and 5 gigs of RAM. If you don't use your capsule after 48 hours, we will shut it down. And we currently have we are intentionally limiting the number of capsules we can support, but that's something that we can change pretty easily. So that's, we plan on adding a lot more capability to capsules in the coming weeks. Our next release of XetHub will remove the limited access so everyone can launch capsules with some guardrails, some limitations, and then we'll remove those limitations over time. So we want to make it so that you can provide your own Docker file. We want to make it so you can specify the amount of compute and RAM you need, what type of container do you want to run? Do you need access to a GPU? All of those types of things. So we really see capsules as enabling one-click deployment for generative AI applications. That's where we're headed. We're early on that path, but that's the direction we're going. Other questions? I will stop sharing if I can figure out how. Disable? There's got to be an easier way. Oh, this little X over here. Let's do that. All right, now I can bring this over here. Ooh, guardrails. Oh, I totally want to check this out. So I think this goes back to Mohammed, Ruben, your question earlier. Thank you, Charles. This is great. Oh, I see a question. Sorry. Oh yeah. Okay. Good. We answered this question already. I like it. Any other questions, folks? We're a couple minutes over on time. I'm happy to stay around, but I'm also happy to continue the conversation in Discord. I see a bunch of folks joined. Hopefully all of you were in the session today when I look over at our Discord. So I look forward to continuing the conversation there. Thank you everybody for participating. I love the questions about movies. I love the questions about the workshop. I appreciate your participation and can't wait to hear what projects you're building, what generative AI apps you're building using XetHub or anything else. I'd love to hear what you're working on. So please join our Discord, share them with me, or drop me an email. I'd love to hear from you. All right. Thank you, everybody. I'm going to end the event now. As I said, you'll get a follow-up email with the recording in a little bit. Thanks so much. Take care.